Hello, everyone. In this session, we will cover cross-validation specifically to marketing mix modeling. We will first start by defining cross-validation. Then we will present the in-sample validation, followed by the out-of-sample validation. Model validation is the overall process of comparing the model and its behavior with the environment to judge the quantitative and the qualitative correspondence with reality. Now, looking at the marketing mix modeling workflow and focusing on the fourth step, which is modeling and evaluation, that's where cross-validation happens. Cross-validation is a very important step in the marketing mix modeling workflow because it is the step that ensures the generalizability of the results that are derived from the models. There are two types of model validation: in-sample model validation and out-of-sample model validation. The first one is also known as goodness of fit. Here, it's about looking at statistics from the sample of the data that has been used to train your model. Metrics like t-stat, p-value, r-square, Durbin-Watson could be used in order to assess the viability of the model when it comes to in-sample cross-validation. Now, out-of-sample validation refers to the concept of testing the model on a new data set, an unseen data set that has not been used while building the model. And here there are two types of methods that fall under the umbrella of out-of-sample validation. The first one is bootstrap, and the second one is cross-validation. Cross-validation is more commonly used than the bootstrap method. In-sample validation. Different metrics could be used in the context of in-sample validation. The first one I could cite here is the t-stat, or the p-value. The t-stat measures the individual significance of each variable. It tells us whether the variable that we are studying has a true impact on your KPI. Generally, we would love to go for t-stat that are above 2 or a p-value that is less than 5%, because it means that there is a true relationship between the independent variable and the dependent variable. The second one is the F-statistic. The F-statistics is used in order to assess the overall significance of the model, assess whether all the variables that you have in the equation have a significant impact on your model or on your dependent variable. The third one is the Durbin-Watson, is a measure of autocorrelation of order 1 of your error terms. The fourth one is the F-statistic that allow you to depict or detect the existence of multicollinearity between your variables. Other statistics that could be considered in the context of in-sample validation, R-square increases each time we add a variable. To control for this and to only depict the improvement in the model that is guided by a true addition to the model, we can look at the R bar squared that controls for this. Both MAPI and standard error of the estimates are used in order to assess how good the model fits the data and gives us a good idea about the forecasting and the prediction power of the model. Out-of-sample validation generally consists of two steps. The first one is to construct and build the model using a portion of your data called the training set, devising all the metrics, all the estimation of coefficients, and the different statistics. And the second step is to validate the model using another set of data, generally called the validation set or the holdout sample. Cross-validation on rolling basis. There are different cross-validation methods, ranging from the exhaustive methods to the non-exhaustive methods. However, in today's presentation, I would like to focus on one method that is particularly adapted to the context of marketing mix modeling. Traditional cross-validation are not adapted to the context of marketing mix modeling because the latter is based on the use of time series. That's why it's very important to pick a method that is adapted to time series analysis. And that's why cross-validation on rolling basis is one of the methods that we would recommend in this context. So how does it work? First, start with a small data set for your training purposes and build your model based on this data set. Then, forecast for the later data points and then check the accuracy of your forecasting. Now, those data points that we have forecasted in the next phase will be part of our training set. And we will be using the model that is trained now on the extended data set to forecast the later points. So we keep adding chunks of data to the training set, and we keep looking at the quality of the forecasting that is generated. That's exactly how the cross-validation on rolling basis works. Thank you for watching our videos. I hope this video was particularly useful to you. If you like our content, please subscribe to our channel. Thank you.